let's look at the next two. So we have this case right here, I see double bonds, and we have this case right here, and I see double bonds. There's only one of the two that can do resonance. Can you identify which one can do resonance and why the other one, why it doesn't do resonance? Hopefully what you're noticing is that there's a double bond here and there's a single bond here. So there's a place for this double bond to go over to. So there would be a second structure. I'm just going to draw it below. Notice this one's neutral, so I don't have to draw the brackets. And then you would just do like a back and forth arrow between the structures. Now, as drawn, this version of this one, there's not a place to alternate because they both are the same. They both are double bonds, so you can't like alternate because they're both double bonds. Now, if we do zoom in on this other picture, because I had indicated that there was another possibility, this one, you could potentially draw a resonance structure for it. And it could potentially look like this, where the triple bond is on that side. So you could potentially draw that. We haven't gotten to, but we're about to get to why, though, that the formal charges on this show us that this isn't the right structure. And then if we look at some of the other ones, here's another one that has a double bond in it. What do you think? Can this one do resonance? All right, so there's not another oxygen to alternate the double bond with. Also, you would never try to give a hydrogen a double bond, right? Because you know that he only has room for 2 electrons, which is a lone bond. There's not a place for any more. So this bond, even though it's a double bond, it doesn't have anywhere. It can't go to those hydrogens. They're single bonds. It doesn't have a place to do it with. Then you'll notice there's no double bonds there. What about this one? Yeah, there's no strong preference. You could do it this way. And you could also do it. Yeah. Make that double bond go down. Fill them all up with all of his electrons. And then you would draw your arrows. Of course, you would normally draw them the same size. I just was trying to squeeze it all here in this little block. Now, just as a little note, though, we're going to find out something about this one, which is also going to affect our resonance. So I'm going to put a big star here. This all has to do within the formal charge business. So we ruled out this one having resonance. We ruled out this one, and then we said this one does have resonance. Look at the last two. This structure right here has nowhere for double bonds to be. There's no double bonds in there. So as drawn, this one has no resonance. And then this bottom one, there's a double bond. That double bond doesn't have a place to move to, though. Those electrons don't. There's not another bond somewhere. There's just 2 atoms. Whenever there's only 2 atoms, you can't have resonance. Let's make sure we get all of these. So this one did have resonance. This one didn't. This one did. We're going to keep going up. And then we talked about how all of these, there's no double bond, so you don't have resonance. Now, it could be that we're going to come up with a situation where the formal charge changes something, and maybe we do end up with a double bond. And then we have to think about resonance again. So that's okay.